Hi to all, welcome to Algotech Programming Concept. In this video session, I am going to compare binary search and linear search on the basis of 10 parameters. So first parameter is algorithm type. So binary search is based on divide and conquer approach. So in this divide and conquer approach, array is divided in two parts, and search will take place either in left subpart or in right subpart. So it will be faster to search the element using binary search approach. And conquer means left sub array or right sub array will again recursively solved. And linear search is based on iterative or incremental approach. And the second parameter is requirement. So to perform binary search on data, the data should be in sorted order. It should be in ascending order or in descending order. But for linear search, the data should, if data is not in arranged, or we can perform linear search on mixed data. And binary search is performed on single dimensional array, and linear search is performed for single and multi-dimensional array. And binary search is faster than linear search, and the implementation of binary search is based on array, and linked list cannot be used for binary search, but for linear search implementation we can use array as well as linked list. And binary search is performed on large data set. It is very faster to search the element from the large database. But for linear search, if we perform linear search in large database, then it will be time consuming. And the mathematical modeling for binary search is T of n is equal to Tn by 2 plus 1. And for linear search, it is Tn is equal to T of n minus 1 plus 1. Please watch the complexity of binary search and linear search uh, in Algotech programming concept. Please watch video for it, how to compute the complexity of binary search and linear search. Now we will discuss the best case complexity, worst case, and average case complexity of binary search and linear search. So the best case for binary search will be if we found the element at center, because in binary search we compute mid element. If we are searching the element which is found at mid position, so it will be order of 1 when element is found at center position. So that will be the best case for binary search. And for linear search, when we found element at the first index. And average case complexity will be order of log n base 2 for binary search. And when we perform binary search, if we are not getting the element for first iteration, if we are getting element after first iteration, then the search space will be half. Search space will be reduced at every iteration. So Tn is equal to Tn by 2, then Tn by 2 will be reduced to n by 4, then n by 4 will be reduced further till we get the individual element. So in average case time complexity, we are getting the element after first iteration. But in worst case time complexity, when we get the item, uh, search item at the last, means our search space will be reduced to half, and further it will break into n by 4, then n by 8, and so on, and at last there will be only one element. So this will be the worst case time complexity of binary search. And the average case time complexity of uh, linear search will be order of n by 2 when we found the element at mid position, means order of n by 2, and half is a constant, so we will ignore. And again the complexity of linear search in average cases order of n. And worst case is that when element is found at the last index, so problem size is reduced by 1 on each iteration, and the method does also one comparison in the worst case time complexity of linear search also. So these are the major 10 parameters where binary search and linear search is compared. So to compute the complexity, Tn is equal to Tn by 2 plus 1. This is mathematical equation of binary search. So please watch how to compute the complexity of binary search. And in average case and worst case, and Tn is equal to Tn minus 1 plus 1. This is the mathematical equation for linear search. So please watch my video on linear search complexity on this Algotech programming concept. Thanks for watching.